value inequalities, which is similar to solving absolute value functions and inequalities, which we're both pretty good at. So we're going to look at two different ways to solve an absolute value inequality. One of them is graphically, and one of them is using the number line. When we are solving absolute value functions graphically, we're going to want to use like the shift method. So remember, we're going to just look at the function, figure out how it moved, and then graph the points that way. But the other thing you need to think of is think about the function as being one graph either bigger than the other line or one graph less than the other line. So what I mean by that is when we look at this example right here, first, I'm going to start with just graphing this absolute value function. So this is the absolute value function, x plus 3 plus 1. Remember that plus 3 means that the graph shifted to the left 3 units, and then the plus 1 means that it also shifted up 1. So I'm going to just start by going ahead and graphing that. So left 3 units, up 1. And then remember, we had a point here at 1, 1, so left 3 units, up 1. Remember, it's just that little V shape. I'm going to go ahead and make that. All right, so that's my absolute value function. And then this is just the graph y is equal to 4, which is going to be a horizontal line right at 4. I'll even put that in a different color. So 4 is right here. So this is the function y equals 4. And I know y is not here, but you can think of this again as substitution. Like we set the two equations equal to each other. It's exactly what we're doing. So even though the y is not there, it is implied because these two functions are equal to each other. Okay, so now that I have my kind of bare backbone functions graphed, I'm going to try to figure out where the solution is on this inequality. So remember, when we're looking at graphing inequalities, we're shading different areas for the solution. So I need to figure out, like, am I shading above this line or below this line, et cetera, et cetera. So how I'm going to do that is I'm going to actually solve the inequality. And so what I'm going to do is I'm going to start out by subtracting 1 from both sides. I can get this inequality taken care of. We actually don't need that thick of a line anymore. So my 1's cancel. So then now I'm looking at, to solve the function, absolute value of x plus 3 is greater than 3, right? Because 4 take away 1 is 3. So just a reminder, the absolute value function, f of x, I know I wrote it here, but the f of x function is that x plus 3 plus 1, and the g of x function is just 4, okay? I'm not going to write that, but I'm hoping you got that was implied by the graph. So let's go ahead. I'm solving two different functions, just like I did when I was solving absolute value functions. So I'm going to solve the function x plus 3 is greater than 3. That's the original function. But then I'm also over here. Over here, I'm going to solve the function x plus 3 is less than negative 3. So notice that I'm still solving for the negative solution, but because it's an inequality, I also flipped the inequality, so I could do that. So then I just solve. I'm going to start by subtracting 3 from both sides. When I subtract 3, I get x is bigger than 0. And then on the right, when I subtract 3 from both sides, I'm going to get x is less than negative 6. What this means is that I'm going to shade to the left at negative 6, and then I'm going to shade to the right at 0, because I want all the x values that are bigger than 0, but all the x values that are less than negative 6. So we'll shade in orange. So because 0 is like so, it's right there. That's all the x values less than 0. And then negative 6 is going to be this solution area right here. So that's the solution area of both functions. again, just to the left of 0 and to the left of -6. So let's look at another one. This one, same thing. We're going to just start by graphing the functions. So let's do that. I'll get a thicker stroke so I can actually see it. This time I'll graph it in purple. So this is f of x, and I'll go ahead and type it this time for you guys. Why not? So remember, f of x, we're actually just looking at the function being the absolute value of x minus 2 minus 3. And then for g of x, we're looking at it being the function of 1. So just y equals 1. Okay? So let's go ahead and graph absolute value of x minus 2 minus 3. So absolute value of x minus 2, the minus 2 means that I shifted right this time 2 units, but then the minus 3 means I shifted down 3 units. So right 2, down 3, that's the bottom of the v. There's no flipping, so I'm just going to go ahead and create my v. There we go. So I'll go ahead and graph my line. All right, there's my absolute value function. And then I'm looking at the graph y equals 1. 1 is right here. It's a horizontal line right there. So same thing, I'm going to go ahead and solve both of my solutions. So I'm going to do the same thing as I did last time. I'm going to add 3 to both sides. So now I'm going to be dealing with the function absolute value of x minus 2 is less than 1 plus 3, which is 4. So I'm going to look at having my 2 solutions. So I'm looking at x minus 2 is less than 4. And then I'm also going to look at x minus 2 is bigger than negative 4. Okay. So let's go ahead and solve. I'm going to start by adding 2 to both sides. Oops, that's not wrong tool. Let's go ahead and do it over here. Why not? It's the same steps, just different math. All right, when I add 2, it cancels. So then on the left, I'm going to have x is less than 6. And on the right, I'm going to have x is greater than negative 2. So this time I'm looking at the area for both graphs where the x values are less than 6. So I'm looking here, I'm going to be looking to the left, and x values are greater than negative 2, so to the right. So really the solution area, it's kind of cool, ends up being the center of the v this time, which is just this little section right here. So that's my solution area. Again, that just means that any number in this domain will be a solution to that inequality. Okay. All right, so then the other method that we talked about having being able to solve inequalities was on a number line. So again, we're looking at if the absolute value of x is bigger than a, where a is positive, then x is less than negative a, or x is greater than a. And same thing over here, if absolute value of x is less than a, where a is positive, then negative a is less than x, which is less than a. So let's go ahead and take a look at this. So on this one, we're going to solve the inequality algebraically and then graph the solution on the number line. So let's go ahead and start by subtracting 15 from both sides. When I subtract 15, Well, obviously the 15 cancels, but then I get 4x, well, the absolute value of 4 minus x greater than 21. I need to solve both of these. So notice how it follows this pattern. Then this tells me that x is going to be less than negative a, and x is going to be bigger than positive a. So this, remember, is an either or. So I'm going to expect my arrows to go in opposite directions because the absolute value of x is bigger than a. So let's go ahead and find out where we're going to graph our points. So to do that, I'm actually going to shift this up here so I have more room to do the math part of it. I'm going to go ahead and I'm just going to kind of get rid of the absolute value of signs in one step, and I'm going to subtract 4 from both sides. So, sorry, before I get ahead of myself, so I'm looking at 4 minus x is bigger than 21, but then I'm going to have over here that 4 minus x is less than negative 21. Okay. So if I subtract 4 from both sides, I'm going to have negative x equals 17. And then when I divide by the negative 1, the inequality flips, if you remember. So I'm going to have that x is less than 17. Looking ahead to my number line, I'm not going to have enough room for that, but we'll deal with that in a second. So then now I'm going to, again, subtract 4, so then I get negative x negative x is less than negative 25. And then when I divide by the inequality, I'm going to end up with, or by the negative, I'm going to end up with x is bigger than 25. And again, that's just because the inequality flips when you divide by a negative number. That should be familiar from 7th grade. So I'm looking for all the values where x is less than 17 and all the values where x is bigger than 25. So because my numbers don't really match up to what I need them to be, I'm going to have this be 0, and then count by 5 is 5, 10, 15, 20, 5, 10, 15, 20. Okay. So let's go ahead and make that. That still won't give me enough room. So let's do, we can count by 10. So negative 40, negative 20, 20, 40. I made the number line. Nice. I just didn't do it correctly. Alrighty, we'll just go draw values through. I just do these because we don't want those. Those are bad numbers. All right. So then my first dot is going to be, we're going to be having an open circle because you notice how it doesn't have an inequality, and my open circle is going to be at 17. So remember we said this was 10, so 17 is going to be about right there. Okay. And I want all the values that are less than 17. So my arrow is going to point down the number line. And then for the next one, I want all the values that are bigger than 25. So we're going to use a blue, and this one again is an open circle. So 25 is like in the middle between. Oops, should probably have the right tool. So open circle at 25. And then I want all the values that are bigger than that. So this is what my inequality looks like. And look, it does match what we thought it was going to be. It has that either or thing going for it. So going in both directions. So we did our math right. And so the solutions are either less than 17 or bigger than 25, but not in between. So let's go ahead and do the next one. We have the absolute value of x plus 4 minus 10 is less than or equal to negative 2. I'm going to go ahead and solve, so add 10 to both sides. When I add 10, I'm going to get that the absolute value plus 4 is going to be, so I have to actually use this tool, is less than or equal to 8. Okay. And then this matches this inequality. So actually this, I'm going to have like a sandwich. So my line that represents the solution is going to be between 2 points. So again, I just got to figure out what those 2 points are. So to figure those 2 points out, I'm going to solve for x plus 4 when x plus 4 is less than or equal to 8. So less than or equal to 8. And then I'm also going to solve for when x plus 4 is greater than or equal to negative 8. I don't need that anymore. It doesn't matter. So solving for x, when I subtract 4, I get x is less than or equal to 4 on the left. When I subtract 4 from the right, I get x is bigger than or equal to negative 12. Okay. All right, so same thing, I'm running into that number line problem. So we're going to just count by 3's going down, but we'll still count by 1's going up. So then this will be negative 12. This will be negative 6. So when you make your number lines, make sure you do a good job. There we go. All right, so then now I'm going to have closed circles because there is a line underneath my inequality. So we're going to have a closed circle at negative 4. Go ahead and fill that in. Obviously, that's not perfect. And then we're going to have a closed circle at negative 12, and then a closed circle at positive 4. So same thing, making the circle tool, and then that one looks pretty close to me. All right, so then the solution area is between, because I want all the values that are less than 4, but bigger than negative 12. So the solution area, actually use a line. The solution area in this case is going to be the space between those two lines, those two dots. Okay, so this means that all the solutions are going to be in here, which is going to be similar to like what this graphically looked like. All right, so now hopefully you can answer what are the 2 ways you can solve an absolute value inequality. We went over 2 of them. I prefer the number line, but go ahead. But the graph one's pretty cool too.